All right, so let me introduce you myself first. My name is Milad Astaner. I'm a premier field engineer, part of the global business support team from Microsoft. And basically, my main specialization is Windows reliability and performance. So I'm troubleshooting every day at Microsoft's most strategic enterprise customers, Windows, and to understand why certain things happen on a nanosecond level. Today we will talk about Windows performance, the impact it has in enterprise, and we'll primarily focus on slow boot and as well as high resource consumption. So high CPU, high disk I/O, and how you can utilize tools like Windows Performance Toolkit or Windows Assessment Services in your enterprise. So let me start my VMs. It's going to probably take a while. Anyone attended how many coffee can you drink till your Windows starts? Yeah, quite a few. So according to Peter's ISO standard, this will take a while. Just kidding, I had all my VMs started already. All right, so what we will cover? Windows internals, basics. I think we won't be able to cover the entire Windows internals book, so I think it's 600 pages, 2 parts in 1 hour. So we will really focus on some of the basics you should be aware of when it comes to Windows performance. We will primarily focus on Windows performance impact. So really dive into what you need to know, what you can improve in your enterprise, and we will have some great demos from the real world. The objective is getting really insights around Windows Performance Toolkit, and not just only seeing it in action, but also giving usability later on that you can really use it. You will identify how Windows works under the hood in terms of boot, as well as how a thread works, how a process works. And the idea is, the key takeaway would be to get ready to improve your IT landscape. So what is Windows Performance Toolkit? Basically, Windows Performance Toolkit had been introduced back in Windows Vista. Yes, Windows Performance Toolkit back in Windows Vista. Yes, we introduced it quite quickly after release. The idea was we ship it to our OEM partners to improve the overall performance of Windows Vista. And then we realized how powerful the tool is, actually, which engineering developed. And we made it broader available to all IT pros over TechEd. And since then, since Windows Vista, we are continually improving it. And it's one of our big bets in terms of Windows performance and understanding how Windows works under the hood. But where do you get it? You get it from Microsoft.com, and in fact, just let me show you it. Let's see. All right. So that's one of my VMs. We have at the moment network issues, which I just realized, so I was lucky enough that I preloaded the websites I need. So you go to the search engine you prefer, Bing or any other ones you might hear about, and just type in Windows ADK 8. Windows ADK 8. This will give you the latest version. And you might say, no, this guy just started talking about Windows Performance Toolkit, and now he's talking about ADK. Correct. The Windows Performance Toolkit is now part of the Windows Assessment and Deployment Kit, and the latest build works for Windows 8 as well as Windows 7. So once you download it, it will just download a little web installer. It's around 2 megabytes. And then when you start that one, in fact, I prepared that, so I have an offline version of it here. It will ask you, first of all, where do you want to install it? If you hit on next, it will ask you if you want to join the Customer Experience Improvement Program. So you would send anonymized data to Microsoft in order that we are able to improve that product further. Read, of course, the license agreement in detail. And then what is important for us, let's just untick those. For us, the most important one is Windows Performance Toolkit, which brings us the Windows Performance Recorder to record performance issues, and the Windows Performance Analyzer to read the log which you generate with the recorder after on. So once you hit install, it will ask UAC prompt will come up to elevate yourself. It will install the feature. That's it, pretty quickly. And now, let me just open the recorder. And in fact, let me put it to the start screen, since in 8.1 preview, we do not automatically put any more stuff to your start screen, because that was one of the things you guys always wanted since 8 release. And now I start the Windows Performance Recorder. And basically, we made it pretty simple now to collect logs. Before this version, it was all command line based. So you need to know the syntax in order to generate a log. Now it's way easier. We have finally a GUI for that. So you basically can choose here now within resource analysis, where do you want to focus on? Do you want to focus on CPU? Do you want to focus on registry activity, network activity? You can choose it however you want. You can combine things. So maybe you want to focus on CPU usage as well as registry I/O activity. So what does a registry write at that certain of time? And on the right side, you can then have the option to say, okay, which performance scenario do you want to analyze? Do you want a general trace? So you would use a general trace whenever you want to analyze something post-boot. So you have, for instance, Internet Explorer takes 10 seconds to start. Then you would go for a general trace. On top, you have the ability to use Windows Performance Recorder to trace on-off transitions. So boot, in Windows 8, fast start up, shut down cycles, reboot cycles. It's all possible. You can all trace that and analyze that with the Windows Performance Toolkit. So let me choose general here as an example. As a detail level, it will ask you, do you want a light version or a verbose version? So what's the difference? The difference is, the biggest difference is that in verbose, you will get additionally the stacks. This means what is actually the thread? Which function is the thread calling to the Windows kernel? And you will get those detailed informations. And lastly, you can choose, okay, do you want to lock this file to memory or to file? Having that said, as soon as you would go for an on-off trace, you would then automatically write it to file, of course. Since it's restarting, it doesn't make sense to write it in memory at that time. Okay, so once you would start it, it's starting in the background some providers from event tracing for Windows, where we will drill into it later on. And basically, you could now reproduce the issue. So reproduce the performance issue. Click on Save once you're done. Write a description, slow, very slow machine. Hit Save. And then it offers you to open it straight in WPA, Windows Performance Analyzer. And within the Windows Performance Analyzer, you then have, on the right side, you would have empty space. Why empty? Because before, in previous versions, we just put a lot of data in there. And people were saying, like, including me, oh, Jesus Christ, like, where do I start? So now, engineering gives us the ability to say, okay, I want this particular graph to be displayed, and I want to drill into that one. So just as an example, I want to focus on lifetime of processes. So I just move it over from the left side to the main part, and I can analyze that one. So that's high level around what and where. We will focus, I promise, later on some real cool case studies and how we resolve that by using Windows Performance Toolkit. All right. So let's talk about Windows internals. When I started at Microsoft, or even before, when I was getting hired by Microsoft, my manager asked me during the interview process, do you have the Windows internals book? I said, yeah. I was lucky. I said, yeah, I have it. And then he said, how many copies do you have? I was like, well, just one copy, right? I mean, how many copies do you want from a book? And he said, it's not enough. So I learned that everyone in our team has 2 copies. It's like mandatory. Our managers ask us, right? One for the bathroom, and one next to your bed. So the first thing I got from my manager was not my laptop, actually. It was a second copy of Windows internals. All right, let's start by focusing on user and kernel mode. When you actually look on white papers from OEMs, you will sometimes see that they refer to it as privileged mode. So the kernel mode often gets referred as privileged mode. I couldn't find the guy who decided to rename it to kernel mode at Microsoft, but I presume they just said, okay, the Windows kernel is inside the privileged mode, so just let's call it kernel mode so people don't get confused. But in fact, if you now go into white papers from our OEMs, you sometimes will see privileged mode and say, like, what is privileged mode? Like, Microsoft always talks about kernel mode, and now they talk about privileged mode. So privileged mode is the kernel mode. Within the user mode, we have the system processes, such as the logon process, Windows services, right? Any Windows service you will have will be running in the user mode. You have any kind of application you will start as a user of that computer, environmental subsystems, and kind of the bridge between the user and the kernel mode will be the anti-DLL.dll, which is an anti-function library. Within the Windows kernel, we then have the Windows executive. Those are base OS level services, such as memory management or thread management. Windows graphical interface, so we can see at least something. The Windows kernel itself. Hardware abstraction layer, HAL, which is responsible, which is responsible to isolate the Windows kernel from the hardware so that developers can write hardware-independent code. And lastly, we will have the devices and file system drivers. I mentioned anti-DLL.dll already, and this one is really important because you will see it in all Windows performance traces. They will always start, a process will start, and there will be an anti-DLL or the kernel 32 DLL. And the reason for that is, let me just show it, in fact, how it looks like on Windows Performance Toolkit. So I took a sample. I started command.exe, which then goes over to kernel 32 and say, create a process, which then later goes to anti-DLL and say, create user process, and ends up in the Windows kernel. So the chain is that the process will contact the kernel 32 DLL, telling him, I need to do certain things. Kernel 32 DLL say, OK, I got it. Let me call my friend anti-DLL.dll. And he will be then responsible to tell the Windows kernel to do certain things. So in this example, it will be create user process. This is an anti-kernel function. Went down to the anti-OS kernel.exe to get executed. When we talk about, with customers, about programs, processes, and threads, there's always a myth saying, like, for instance, a program causes high CPU usage. A process causes high disk I/O. That's not correct. In fact, any hardware resources are consumed only by threads. And I refer to it like that. Think about the program as your area manager. He has a sequence of instructions, so he can say, OK, you're my people manager, and I have these instructions for you. And the people manager, the process, is now responsible and has some 20 threads under him, his support engineers, telling him, OK, you know what? You are responsible to get me a coffee. You are responsible to wash my car. And those guys would then execute code down to the Windows kernel and say, oh man, my manager just told me I have to wash the car. So the anti-kernel function, wash my car, I have to execute it. Sorry, man. So that's how I refer to it. So the program will manage everything on the high level, on the strategic level, goes down to the process, and then lastly, the thread, the hard-working guy, will be responsible to execute certain stuff. But how does a thread now get CPU time? So how does this hard-working person, hard-working thread, comes to the CPU? On a higher level, we have some queues, right? We have one queue where it sorts by the threads as well as the thread priorities. So maybe you saw on Task Manager, it says priority high, medium, low, and so on. We then got the CPU scheduler, which looks into this queue and say, OK, I have some work to do. I need to move those guys away from my queue. And that's where the ready queue kicks in. So the CPU scheduler moves those threads to the ready queue, and as soon as something goes to the ready queue, there's a dispatcher saying, oh my God, I have a fire drill here, I need to work, and will then put those threads, depending on their thread priority level, to the CPU. By the way, all of these switches, all of the time when there is a thread moving around, so we refer to them as context switch. So a context switch appears every time a thread moves to its location, let's say, okay? Or the thread, and that's really ideal word, is on the CPU and say, you know what, dispatcher, I got everything I need right now. I might come back, so put me in a waiting queue. Or what more likely happens, the time dispatcher gave those threads elapsed and he just removed them. So that's how a thread comes actually to CPU, and you guys can work on Windows. Let's talk about Windows boot. We start with phase 0 start. We then do a HAL initialization. Don't panic. You don't have to know that much in detail about the Windows boot. In fact, it's way simpler. So we have three main portions. We got the BIOS initialization, OS loader kicks in, and last portion is OS initialization. Where we focus when we talk about Windows performance is the OS initialization phase. Within that phase, we have the Windows kernel which gets invoked, session initialization, so the session starts, and as well as Windows services starting slowly. Then we go over to WinLogon, which is basically the time where the users see, oh, you have to click on strg and also on, and to enter your password. And in that time, by the way, group policies, computer group policy gets started. We then go over to Explorer initialization. So the end user typed in his password, hit on enter. And in Explorer initialization, it's the first time Explorer.exe starts. And the user GPO would get invoked there. Lastly, we got post-boot phase. Post-boot is accomplished, so done when CPU and disk manage to get 80% idle over a time frame of 10 seconds. This is really important to know because in the past we saw support cases, primarily from end user to help desk, saying, oh my God, when my machine starts and I see my mouse, it's just so slow and it takes a couple of more minutes. Yes, most likely reason, or really number one reason was in the past, post-boot phase was not accomplished at that time. So in the background, there was still some auto-start application, delayed services starting, and the end user didn't see it. If we put that in a process perspective, we have the BIOS, which invokes MBR, master boot records. Boot MGR starts. We then go over to WinLoad. The Windows kernel, NTOS kernel.exe starts. SMSS, service manager, session manager starts. Goes over to CSRSS. And later on, WinLogon kicks in with LSAS for authentication. And finally, Explorer.exe. So you might say, oh, why is this guy keep talking about executables? Those executables are really important to know because when you're troubleshooting a slow boot issue, you will see exactly those executables. And if you don't know how long each of those processes should take ideally, well, then you will open TechNet and MSDN and search for white papers. Because you need to know that NTOS kernel.exe is a Windows kernel, and so on. So where do we get all that data from? So where does Event Viewer, where does sysinternals tools, where does Windows Performance Tool gets his data? All that kind of data comes, for the majority of time, from event tracing for Windows. ETW has been introduced to Windows with Windows 2000. It has become a major, got a major update when we shipped Windows Vista. And the idea was we have one framework where everyone, including Microsoft, can put basically their logs. The big advantage also, it not just only scans or looks after the user mode, but it also checks the kernel mode. You might say, okay, that sounds like a whole lot of data. That's true. It's a lot of data which you can log with event tracing for Windows. But In fact, 20,000 events which get generated every second will cause us a few percentage of CPU time. So before, when we talked about one-core processors, it was like our statistics showed us it's around 5%. Now with dual-core or even more cores, we are at the 1 to 2% of CPU utilization. When we talk about performance and focusing on slow boot, there are 4 main components where we see there are some areas to improve, let's say it like that. First of all, startup scripts, as well as logon scripts. The problem with that is that usually what happens is that those logon scripts do stuff like add a printer, change permission, assign a driver letter, assign a network folder, and so on. In fact, who has a startup script in their company? Unfortunately, I have to do it as well right now. We keep MSIT pushing right now to remove them. We are in a good way. We removed, like, I think 80% already. Why could a startup script cause performance issue? First, group policies is always faster in processing. Even if you have a group policy which has item level targeting, it will be processed quicker by the system than any of your startup script. Also, think about this way. With group policy, if you go with group policy and group policy preferences, you will have one channel where where you can quickly see any possible errors, which will be event viewer. You don't have those options with startup scripts. Next problem is filter drivers. The problem with filter drivers, most of the times when I'm on site or one of my colleagues, is that they hook up in certain areas where they shouldn't be, or the customer has an outdated version. Really, like, you might think about, oh, what are those guys doing on customers? Well, those are really the first things we look after, and most of the times, really, it's just updating certain things helps a lot. To give you an idea about that, I was once on site at one of our major airline partners, and basically what happened, they had some sort of startup applications. And it was like to change the screen rotation. One was for audio configuration. One was for PDF documents. I just removed them. It was 20 seconds faster in boot, the entire enterprise image. And then the manager said, yeah, just 20 seconds. Who cares? I say, yeah, you're probably right. Let me calculate you by your average income, like the average of each employee, how much you can save. And I just took 20% of that total number. It was 8,000 euro per day. And then, out of suddenly, the guy said, oh yeah, that makes sense. We should remove them. So don't think that 10 seconds, 20 seconds is not that much. If you put a number in, and I really just used 20% of that whole money stack I calculated, it's a big difference for your company. And well, we also have Windows services. So why are Windows services can cause issues? When we start Windows services, the system oriented itself by groups. So any service is in a particular group. So we have a network group, we have an authentication group for services. What do you think antivirus or firewall vendors would like to have their services to get started? At the very end or at the very first time? Who is for the very end? Okay, one. Who is for the very first? Cool. Yes. So primarily, most of the times we see that they try to be one of the first, which I don't say it's not bad. It's bad. I say yes, it's good. But sometimes it happens they forgot about dependencies of their services. So what happens frequently at the moment is the antivirus service will get started at the very first time, and then it has a dependency on the network services. What happens is a 160 seconds delay in boot, because their service, the antivirus service, will get timed out. It's waiting on something which is not there. So at the end, 160 seconds later, network services get started, and then something happens in the system. You say, wait a minute, I'm still not started. System goes back, starts that service, and the boot continues. That's why it is important to look after Windows services in Windows Performance Toolkit as well, and I will show that later on. Lastly, group policy. So you might say, oh, man, the guy just recommended group policy, and now he's complaining about group policy. The problem with us IT pros is we try to be Picasso when it comes to be on design work on certain things. In fact, also on group policy. So we try to overthink. We try to have thousands of variables designed about WMI. Please don't. And I did that by myself in the past and realized how big the performance impact can be. We say, use group policy preference, definitely. But don't overcomplicate those group policies. Use it simple as possible and really just test the performance impact before you roll out a group policy. What about application? Application impact. I mentioned one of our customers who volunteered, by the way, that I can talk about that. It's not like I'm just talking about on the back behind them. I'm actually frequently on site at that customer. Are you guys aware of autoruns from system channels? Yeah, somewhere necks are shaking. Okay, so let me just show you it. Okay. No. Oh yeah, that worked. All right. Tools, system journals, autoruns, run as administrator. So, as you probably are aware, you could check on MS-config auto-starting applications. We moved that feature in Windows 8, by the way, to the task manager. But the limitation of it just show you the system portion, not the user portion. Autoruns from system journals gives us the ability to see every single corner where auto-start application, add-ins, add-ons, anything which is auto-start related will be listed there. So what we are doing frequently is when we go on-site, we use autoruns. First get a general overview, so we go over to log on, we go through Explorer. Basically, we go one by one and look first of all for anything suspicious. By suspicious, I mean potential things which could end up in malware. And some of the tools we know from experience, they are most likely causes for performance issues. And once we are done with getting a general overview for us, we start simply disabling for a moment certain processes, do a Windows Performance with Windows Performance Recorder a trace, look at the performance impact, and then continue till we find the bottleneck. So if you are really interested in Windows Performance and you want to baseline also maybe your application impacts, that's a really cool tool you should know about. All right. Mentioning baseline. Anyone know the Windows Assessment Services? One, two? Cool. Yeah, that's also when I go to customers. It's maybe one guy maybe saw a TechEd article about that. I'm not sure why we don't push that more, like in terms of marketing, because it's a really powerful tool. So the idea of Windows Assessment Services is, first of all, it's a free tool. That's always good. To give you the ability to baseline your enterprise image. Even you can baseline the duration it takes for your deployment of your enterprise image. So you install Windows Assessment Services, it will create an inventory of your machines, and then you can use certain jobs to be run on your lab environment. So you can say, I want to analyze the boot performance of 20 machines in my lab environment. So this is all possible with Windows Assessment Services. It's a great tool to get you a baseline trace from your enterprise image, as well as how long it takes in terms of media experience. So how long does your image take to open an audio file later on, or video file? How long it takes to open Internet Explorer? You can baseline all that with Windows Assessment Services. All right, so let's start with some interesting demos. So, who doesn't know him? Oh, you're joking, right? He's laughing, okay. All right, so Homer is taking a nap for the next 10 minutes because his machine just takes too long to start. Not sure what Burns would say about that, but let's find out why his machine is taking actually so long. All right. Let me just show you that machine. All right. So what I will do now is I start the Windows Performance Recorder. And in fact, just to show you that it's really a managed device and all that, let me open System. Here, Contoso.com. What a surprise, right? Microsoft presenting Contoso Limited. And now what I will do is a first level triage scan. So first level triage means all the most important profiles has been collected to one triage. So you don't have to choose like, I want to just CPU, I just want to registry, all that. You will have in first level triage all those important information in there, so you don't have to choose it one by one. I want to have a boot trace. So I choose as a performance scenario, boot. Want verbose logging, so I get the stacks. I write it to I write to file, since it's a boot trace, and I just want to have one trace. So let me start it, and now it will ask me for reboot the machine, since it's a boot trace. And next is, yeah, he will kick me out, and it will take some time. Since we didn't want, like, I think nobody wants to wait now 10 minutes till this machine starts, I got the trace ready. I took it earlier. So here I got it open. So what I would do now is, under System Activity, I will first grab the boot phases graph, pull it over here. So this will give me a general overview around each boot phase, so pre-session, BIOS, OS loader, session initialization, WinLogon initialization, Explorer initialization, and so on. And I can now look into which of those phases takes the most of the time. Anyone wants to guess? Huh? Yeah, the green one, huh? Exactly. So how long does the green one actually take? So WinLogon init. The duration is 604 seconds. Quite a few times, huh? 10 minutes. Luckily, we have a Windows logon graph as well. So let me pull that one over here. So here we got the Windows logon graph. Pulling it over. Just going to close that one now. And what I just do now, since I see the big portion over here, I just tip on it, and it will open the corresponding informations till I go over here, where I can see that between the 604 seconds, out of that, 600 seconds precisely are spent in GP client, which is group policy. But that's not enough for me. So I want to know which group policy gets loaded, which group policy takes so long. You can do that by using the graph which is called generic events. So the idea of generic events is basically, since we rely on event tracing for Windows, it will give us a whole lot of providers. In fact, if we would decide to design for each of those providers a graph, I think engineering would stop developing Windows and focus the next 10 years on designing graphics for those providers. So anything which doesn't have a graph will end up in generic events. So I got it here open. Basically, I choose on that big list, let me close that one for a second. So here you can see all those providers which I captured at the same time with a first level triage trace. And I want to focus on Microsoft Windows group policy. Microsoft Windows group policy. And now basically you can see on the right side the time. And I just scroll down now slowly and follow the time to see where does a big gap starts. Oh, that looks good, 5, 6 seconds. Everything looks good. Some GPUs get loaded. There was some authentication before. That looks all good. But here's a big gap, right? So from 6.693 to 606. What is it doing? Let's have a look. So you will always have a so-called opcode, which says when start. So something is starting to be processed, and hopefully when stop should be there shortly after. Then you see the username which has been utilized to authenticate to AD. In this case, it's corp, the domain, A00 whatsoever. And what is it saying? I think log on script. So the log on script gets at time executed. And if you now look here, this one is really important. Is script sync? True. Why and what is that? So what is it? You can choose in group policy if you want to process your scripts asynchronously during boot. This means that they will just get started after another. They won't wait till the first one is over. Or you go with synchronous to make sure that this script gets executed and it blocks everything behind the scene till this script is done. So basically, this information here confirms that this script is processed synchronously, so it waits. And in total, the win stop comes after 600 seconds. We can look in the process lifetime, and we can also confirm that here. So here you can follow the process ID and the parent process ID. And if you look over here, you will find gpscript.exe here with the process ID 1456, which is starting command.exe. And command.exe, you can see the command line which has been utilized. Basically, it goes to contoso.com, to the domain, to sysvol, to the particular group policy, and starts a batch file. And here you can again see start time, 7.0 seconds, end time, 606 seconds. What do you think could be now the reason for this delay, the timeout? Yeah, it goes in that direction. In fact, let me just go over. Welcome back, Homer. So we took a look at the boot phases. We identified it's something happening in group policy. We took a look at the process lifetime. So before Windows 7, the default timeout value, which Windows waited till a group policy script would get executed, was at 2 minutes. In Windows 7, we changed that to 10 minutes. 10 minutes equals how many seconds? 600 seconds. What I want to point out here is there's a group policy where you can specify the time you want to give your system till it runs out to a timeout. It is important you test, if you have a logon script, which most of us has, test how long in average those logon scripts take to get executed, and then use that group policy to reduce the amount, because you don't want that 1 or 2 users gets affected because of whatever reason that this script runs some timeout and waits 10 minutes. So specify maximum wait time for group policy scripts would be one of the good group policies which every enterprise should have after testing it in their lab environment. Let's talk about Surface. and surface performance. Oh yeah, happy to hear it. Okay, yeah. So this one is one of my last minute labs. In fact, the reason for that is it measures Windows 8.1 preview performance in a managed Surface Pro. So on that one. So I thought, like, I want to know now how long does my machine take? How long will my Surface Pro take with Windows 8.1 preview and a domain join with group policy and everything? It's 9.1 seconds. So my Surface Pro, and I would presume in average, because we have really a lot of group policies, and it's connected really to the Microsoft corporate network and everything, takes 9.1 seconds till it boots. So that's fast. So sometimes it happens in the computer that CPU is nearly melting away, and memory is complaining to CPU saying, oh, please stop melting. Let's analyze it. All right, so let me open high CPU. So the first graph for a high CPU case I would like to take is on the computation one. So it gives me information around the CPU usage. And, well, if you just look on the graph, you will already see a spike going pretty fast up and remains there like forever. You can hover over it, and you will see which process it is. In my case, it's CPU stress.exe. One of our executors, when we want to analyze CPU behavior, we use that one, so it just goes up about 100%. And under the summary table, so below, you would have also the information, okay, how many counts it had, what's the weight, and you also get the weight in percentage. So here it's 85% CPU utilization. And if you open it and just activate the stack area, you will see ntdll.dll, which is responsible for nt-kernel functions, thank you, would execute certain of things. So it starts a lot of threads, and it goes down to the CPU stress.exe, where it will execute some more functions. So you might say, okay, so why do I see here the function and I don't see anything here? Reason for that is, in order to do stack walking, you need symbols. Microsoft has a public symbol server where you can download them, but of course we don't have the symbols for all possible executables for our vendors. So every time you don't have a symbol, you will see a question mark and nothing behind it. So in here you can see we do have the symbols from Microsoft for Windows. So it tells me ntdll.dll user thread start, which is a function. I got this information from the symbol, but I don't have the information what's happening with CPU stress.exe. But it gives me a good understanding here, pointing me, say, you know what, this performance issue comes from CPU stress.exe and has nothing to do, for example, with the Windows kernel, because the Windows kernel goes through without any problem. Yeah. Additionally, you can also go to the process lifetime. So under system activity, you can choose that one. And there you can see also the processes which has been started. Okay. Let's look at high disk for a second. So this is a high disk I/O case. And let's first open the system activity. So I want to have the processes. I want to know which process got started. One of the cool things with Windows Performance Toolkit, depending how you use the columns, you will get other more detailed informations. So for instance, if I right-click on the columns area, you can have additional information. So for example, you want to know the parent process ID, which I just demoed, or you want to know the creation information, developer information, session ID. So in which session is this executable running, this service? you can have that all information displayed. So I can see that there is a particular executable that looks a little bit suspicious, just called diskbash.exe. Doesn't sound like an enterprise app. And if you now look carefully on the Graph Explorer, you see that where the disk bash got executed, pretty much at that time, disk usage goes up to 100%. So now next step would be moving over the disk usage graph over here. Oh, that was the wrong one. All right. And now, again, just like with the high CPU case, you can hover over here, and you will see on which disk this issue happens, so disk 1. And in fact, let me just move now the disk column away, because I don't need that one. But what I am interested in is more about the process. So let me move the process over here. I don't want to know about the priority. It's not related to my issue right now. Close that one. Make it a little bit bigger here. And now you can see the I/O time spent on this bash compared to the others. It's a huge difference. Let us open it. And you will see now a lot of write activity within the disk. So you have the confirmation that diskbash.exe is causing 100% disk I/O activity. All right. Any questions so far? We got nice ladies with mics, by the way. No? Okay. So yeah, that was a high CPU case. We just hover over it. We can see it's CPU stress.exe. I could have used really complicated traces and drill into, but those cases, how we looked into it, majority of time when we are on site, it's that simple. It happens that actually once I was on the highway and was a little bit fast, around 220, and got a phone call from one of our resource coordinators, responsible for EMEA, saying, Milad, you need to fly. I said, I'm on holiday. Call me later. I said, no, you need to fly to Austria. There was a big outage due to performance issues on all the clients, where basically it took, I think, like around an hour till all machines from a financial institute starts. And I was still the closest one. So they asked me, can you just fly over? I said, yeah, sure. Luckily, I was next to the airport, called in our travel agency and arranged everything. I was there. Basically, what happened was there was an update from a vendor for their storage. And it was one executable. I opened Windows Performance Recorder, I traced it, and looked into it and said, I don't remember the executable name, but it was something with, it was some sort of executable from that related to storage, and it was just causing 100% CPU time. I told them, thank you for being now in Austria. It's a nice country, I like to be there, but we are done. What the? So we just opened a casino on the other side. So that was the feedback from MMS Las Vegas to get also casino in Madrid. We did it. No. So really, it was a 5-minute on-site, and it took us like 5 hours to get there. We had 4 escalation engineers available on the phone. It was not necessary. If you know Windows Performance Toolkit and you start using it, you will be fine. And there are a lot of good TechNet articles around that as well, written by PFEs, by escalation engineers with screenshots. I really highly recommend using it and start using it. Yeah, so high CPU. Oh yeah. So anyone attended the session from Alfred Ojukwu around changing the deployment to UEFI? Yeah, some? Yeah, cool. So I thought, okay, now let me compare Windows 8.1 Preview performance, UEFI versus BIOS. Some of you might be aware in Windows 8.1 Preview, we give now the ability in client Hyper-V to virtualize Generation 2 machines, which is UEFI-based machines. So I could demo it. So I looked into it, say, okay, how many coffee can I drink till my BIOS starts? Just kidding. So a clean Preview machine, non-domain joined, just installed plain, nothing special, no software, 8.1 seconds. On my i7 machine, I assigned 4 gig of RAM, SSD. What do you think UEFI takes? Who say more than 10 seconds? You listen carefully. Perfect. It's 4.2 seconds. Same conditions, same hardware, just the fact we utilize UEFI firmware, not the BIOS. 8.1 Preview, 4.2 seconds with UEFI. So more than the half. I was myself amazed. Like I thought it's maybe UEFI will be like around 6 seconds, because that's what my customer would say. Oh, we don't go to UEFI, and it's not that big the performance impact. And now, since I had the ability finally to test it without getting additional hardware, I just did it and found out it's 8.6 versus 4.2 seconds, which is impressive. Not to mention all the security functionality I get with UEFI. All right. So, any questions? No? Some? No? Okay. Some related content. The first 2 blocks, I contribute to them as well. So it's MSPFE. You might saw it already. It's one of the top 3 TechNet blocks at the moment. It's created by Premier Field Engineering Group, as well as PFE Platforms, which is more coming from the US side. MVA, Microsoft Virtual Academy. You will soon see a lot of Windows performance related training courses. I know that because I wrote them. And beside of that, you will have like all the jump starts and everything, all MVA. Microsoft Services, if you want to know about Microsoft Services a little bit more, and you can still find me in the Windows Enterprise booth. Please, and I'm sure you didn't hear that so far on TechEd, fill out the eval, please. This will help us to improve the content further. Well, and thank you.